rather easy to remember because we are just working with one angle, which is phi. We don't have two angles, and we are just working with cosine, sine, and then minus sine, cosine. So that's something you can remember. So having said that, we can therefore see that I still reintroduce my, and remember that we found phi earlier. Remember phi we found out to be this value. When we are finding P in the law phi and z, we found this phi to be equals to 108.4. Just in case you have forgotten, it is right here. This is my phi. That is the phi we require. So what do we do? I want to move a bit slower. So what we do is just we do that multiplication. What we also remember is that with these ones we know, because we have been given that A in the rectangular coordinates is given by Delton is asking where we are supposed to register our names. By the way, as long as you have logged in with your registration number, don't worry, I will be able to get that list. It is the other platform that I was using that does not allow us to register. But with the platform that we are using now, I'm going to be able to get your register full. So don't worry about the name, Shelton. You are safe. But those who have written their names is still fine. You don't have to go and read it. So remember that we have been given that my A is equals to 6y. Is it 6y? No, 6ay plus ax. Remember, that is what we have been given right here. So this is the one that we already know. And therefore, I have said you can express it in this form. So this is my ax, this is my ay, and my az, or my az is equals to 0. This is equals to 1. This is equals to 6. I'm moving. I normally don't move that slow, but for the sake of those who might get lost, I'm moving slow. So this is my ay. And if you are to, this is my a vector in x, y, z coordinate. And therefore, if we were to express it as a column vector, we just put your y here, which is going to be, when you transform this one, it is going to become 6, and it is going to become 1, and it becomes 0. So I'm just saying that you place it exactly the way you are told, the way it is represented by my vector A. So, but there is something tricky right here that you definitely need to get cautious about. I hope Shelton got my answer. If you got my answer, you respond so that I don't have to respond to you on chat. You write to me, but I respond to you via verbally. So respond to confirm that you have got my answer. So there's something tricky here. You might be tempted actually to put these values x. I thought I've already been getting tempted here. That you put your 6 there, and then you put your 1 there, and you put your 0 there. That is a problem. That is where the trick is, because you need to write your error, because at some point, what I just need to remind you is that we would do this, we would change this one if you are going to express error in terms of error. Okay, sorry, let me write it a bit slightly different and say the following. That if I was going to write, yeah, you're welcome. So if I was going to write my A vector as A raw AX plus A phi AY plus A Z AZ, then we would place these values directly here. We would place these values directly here. But because we are changing the unit directions or unit vectors, each of them it is becoming A row and A phi and AZ, we have to express my Y, this Y, in terms of row and phi. And I have to express my X in terms of its definition in cylindrical coordinates, but this Z remains the same. So that is the tricky part. It is very tempting because I was also getting tempted to do that, but that is not how you do it. You must, at this point, because of this transition between AX, AY, and AZ to A row, A phi, and AZ, you must change my Y to be expressed in terms of cylindrical coordinates and your Z in terms of cylindrical coordinates. So having said that, we now express this matrix in this form. My A row is equals to, for those who have forgotten, we normally do this row times this column, this row times this column, this row times this column. So I'm just repeating that for those who might have forgotten. Some things are rather easy, but unless they are repeated, people will get lost. So so we carry on. So from that, you are definitely able to see that my A row, the first one, is going to be this times this, which becomes Y cos phi plus sine phi X plus Z, which is X plus Z times sine phi. But of course, 0 times 0 gets lost. We don't have to bother with that. At that point, we substitute my Y with its cylindrical equivalent. Okay. So what we do is that we say that now this Y becomes rho sine phi, and this X, remember my X here. Sorry, where am I? Yeah. This X becomes rho cos phi, but the Z remains, so the Z remains to be the same. Then sine phi. If I'm recording. Yeah, I think I'm recording. Okay, then of course you remember to multiply with the sine phi there. And how we do that is we will solve that later. For now, we are doing the expression. Then I will move to the second bit, and again, we can just remain at that phase. And let me grab some of these things that might confuse people. So I want now to do the second one, which is this A phi. So A phi here is going to be equals to minus Y minus sine phi times Y, minus sine phi times Y. So it becomes minus Y sine phi plus this cos phi X plus Z cos phi. So that again, we remember to replace my X and my Y so that it is in terms of A row and phi. And remember, we have just defined these ones here, right here. So it becomes rho sine phi and rho cos phi for X. And of course, you open the bracket, becomes this bigger bracket, or this opened bracket right there. So this becomes my A phi. And you can see that this is going to become 0. My AZ is still going to become 0. So just recall that if you actually do this multiplication here, 0 times Y plus Y times X plus 0 times X plus Z, then Y times 0, all that becomes 0. So we don't have to get confused. Now we have my A phi, AZ. Okay, I have my A row, A phi, and AZ. But now I think for the simplification, for simplification, we can solve each one of them at a time by doing something very simple. Remember that we said rho is equals to root of x squared plus y squared. But we know x and we know y. This actually becomes root 40. And we can still get my cos phi, the one that we need here. And we know that it is x over rho. And we know rho is root 40. So we can say that that is going to be equals to root 2 or negative 2 over root 40. And the last one is sine phi. And we know my y is equal to 6. So it's, of course, this is supposed to be equals to y over rho. So, and y is equals to 6, and therefore rho is root of 40. You get this to be the answer. So why we are doing that is to find the work for us, because now we just come here and say my a rho is equals to rho, which is root 40. Sine phi is equal to a 6 over root 40, and cos phi is equal to negative 2 over root 40, plus rho again, which is root 40, cos phi, which is negative 2 over root 40, plus z. This is plus z, and my z is 3, times sine phi, which is 6 over root 40. So when you, of course, now simplify that mathematics, this gives you minus 0.949. This is equivalent to, remember you are looking for a rho. Therefore, a rho will now fit very perfectly because it will now become a rho, a small a rho cap. Therefore, we'll just put that directly without now getting worried. How are we introducing the a rho? What we opted for is to convert this to be in cylindrical coordinates, because if we never converted this one, we would have been required to convert each one of them. And that is another approach that we can still use. But for our purposes, when we convert this, we don't require to convert this. But if we don't convert this, you'll require to convert the unit vector, like we did last time. So that works for my a rho. And now we can use the same parameters that we have used to get the what becomes my a phi. And just remind you that we are doing this directly. That you're saying that rho is equals to root 40, sine is equals to sine phi is equals to minus plus 6 over root 40. Sine phi is the same. So I just opted not to put them under the square, like I have put them here, because it is much easier to work with them that way. This is equals to 40. For those who might still be missing the point, I'm just saying this. This is equals to this, and again, the same as this one. So what you do, you just now that simplify, and once you do that simplification, you get that a phi is equals to minus 6.008. 6 minus 6.008. And of course, we have seen that my AZ is equals to 0. So remember the question was to express A in terms of rho, phi, and Z. And we say that this is going to become A rho, that A rho plus A phi cap plus AZ cap. So this we have already found to be 0. This we have found to be minus 6.008. And this we have found it to be equals to minus 0.949. And therefore, our final answer should be minus 9.48 or minus 9.49, which is this one, and minus 6.008 is this one. And therefore, because my A is equals to 0, we this becomes our final answer. Derek Ball is telling us to repeat on 6 over root 40. Where? Here. You can actually, I can enable you to denote so that you can allow you to add some annotation. So please annotate. Show me where you want us to repeat. Just point, I'll see. So again, when I wait for yeah, Joseph Mwagi have recorded the video. Of course, Mwagi is asking, how do you get the recorded video? I always said the recorded videos on the classroom. I said the links on YouTube, and therefore everyone should be able to get the links, which I have uploaded. All of them, nothing that I have taught before, I've not uploaded. And for those who may not, who might have missed that out, I can show you here. Oh, where is Mogi? Oh, I can see you are trying to notate, but apparently I couldn't see. So apparently you have to show me again. What is happening? Disable participants. Okay, so I was saying that I have uploaded all the videos, and I can show you where they are. Google Classroom. What is this? This is now hanging. Okay, I think we can put that on this one here. I can even put it on this other side. The Google Classroom, I've sent all the links. If you look at this lecture recordings, if you are still not managed to join the class, it is the high time you joined, because all the lecture recordings, I said them every time. So you can see all the links are here. The first one we did, the lecture 1, then lecture 2 had 5 videos. And for those who might have watched the video, this one is supposed to be the introduction. So this is supposed to be the first video before this one. So you need to watch it in case you never did. Then the lecture number 3 is this one. So there are 4 recording, four versions, or rather 4 different files that are following in order. If you actually need to follow, they are actually ordered properly. This is 00, 02. Okay, you need to go 00, 01, 02, and 02 and 03. So make sure you follow them in that order. I think I have even indicated here. So that is for those who are asking about the class like Mwangi, please be sure to look at them there. All right, where is Derek? Derek, you're asking me to repeat someone. Okay, someone is saying that they don't want their name to be called. I will not call you, but there are going to be more tutorials. You're always good to have more tutorials. Whoever asks that, you can respond to say that you have heard. They are good. Always, my plan is that from the schedule that I have already shared with you, every week we're supposed to have 1 lecture and 1 tutorial. And as I mentioned in the beginning of the lecture, or the beginning of the semester, we said that I was supposed to be given a teaching assistant or a GA who was, I have not been given yet. Because now I'm not been given, therefore I'll do tutorials myself. So that's why I'm doing it today. I think I've answered all the questions that have been asked, except for Derek. Derek, tell me, you can explain further where you want us to repeat. You're saying repeat where there is 6 over root 40. Why is 6 over root 40 now? Here or here? Just tell me. You can explain it quickly so that we move on. Salala, I've stopped sharing. Let me share again. I was trying to do something, but then it happened by mistake. Don't annotate, just, okay, I have disabled annotation, just describe. All right, I can still enable you because people are annotating and then they are messing up my table or my screen. Okay, I've enabled you to annotate then. Why is that? Goodness. Ah, yeah. Do it now so that I can see. Okay, I've seen. Sawa. Huko ni mbali sana bana. That is quite far. Very far. But nevertheless, I will try to do that. That is quite, what do you mean? We already said, okay, fine. I'll move very quickly. We have said that this is how we have developed, I have developed this one. And I believe you don't have a problem there. So, and I believe you don't have any question with regard to how we are doing this or this. So all we are saying is that we know that that sign of, we have developed them here, right down here. That sign of phi is equals to 6/√40, and cos of phi is equals to -2/√40. Is that clear now, Derek? Because once you know that, the other thing is mathematics. Once you know that this is sine phi, and this other one is cos phi, then I guess that is clear. Confirm that we can move on. Anybody else with a question or concern while we wait for Derek? Newton Sila, include your registration number. Who else? Lois Jockey, include your registration number in your name. Just rename yourself, possible. Okay, Derek is not saying anything. We will carry on. So I think I've seen, yeah, I think I had missed that part. I think he's okay now. So, okay, Derek, that is good. So we have done expression of A in terms of rho, phi, and Z. What we have not done as of now is expression of A in terms of R, theta, and phi. And notice here that I decided that you don't become the observer, you do this bit. Just following this example here, follow this one, and be sure that you are able to do it on your own. And I'm now looking for the question. Confirm that there's nothing we have not left. Oh yeah, so what we have now remaining, so I'm jumping number 4. I'm jumping number 4 for you to do. So this is your task. So I'm going to do A in terms of cylindrical, A in terms of Cartesian, but then this is the reader to do this. So having said that, then we can jump to that section. That we want now to express A in terms of X, Y, and Z. I think this one you already did because we said A is equals to AX plus AY plus AZ, and therefore we said that this was 6AX plus AY, and we said the other one was 0. So that is, with that we have already done. So what we are now remaining is to express AY in terms of rho, phi, and Z, and we are saying that it's actually up here. Just a minute. I think these two questions are the same. I think these two questions are the same. Coordinates. Root A. Routing A at that. Because I think that still works. This is still the expression. This, what we have obtained here is actually the same. This is A in terms of, this is in terms of rho and phi and z. So I think this is sufficient for us. And I think that should mark the end of our today's tutorial. So it's supposed not take long, supposed to take a few minutes, but we have taken about an hour because we had some challenges at the beginning with Google Classroom. Not Google Classroom, we had problem with Google Meet, worked horribly. Now we are better off. So I'm still stopping sharing. I never intended to do that. But now that I have finished, do you have any question? For those who are having problem joining Classroom, this is how Classroom looks like. It has you just make sure that you have logged in with your Dakut email. You can see I've logged in with my Dakut email here. So log in with your Dakut email. That's the first step. And I know we solved all the problems with for those people who had problem accessing their Dakut email. Once you have logged, if you don't know how to do that, just change. If I change from that, it is going to take me somewhere else, which is not what I want. It will give me other classes which are not part of this class. So that is not what we want. What we want is that you must log in with your Dakut email. Once you have logged in, you just need to come. Okay, now you'll find yourself somewhere like here. It will now present you with such a platform. Therefore, if now to join, you just need to copy the class code that I gave you, and you say join class, and you paste it here. In fact, if I just there's someone who had sent me an email explaining that. Let me see if I can find that email. Just a minute. There's someone who has written me an email, I think a day ago, or let me see who that is. Who was telling me that they are having a problem, and I told him to get back to me, and they have not. So I want to show you very quickly. Let me get my class code, and you see what happens when you join with the class code. Okay, I got, yeah, there's someone called Evans. Evans who? I'm not sure if he has joined. Let me confirm. Evans, yeah, Kiprop Evans telling me that he's having problem. So he has given me even the class code. But the problem with Evans is that he is not logging in using, oh, he's telling me that he has even the good email. But problem, he might not be changing. So when you paste the class code there, you'll actually, and say join, it will tell you that you are, of course, it will join because, just a minute, ask the teacher for the class code, then enter it here. This code is not valid. Make sure that you type the correct code. I guess it's because I've already joined the class. Otherwise, if I had not joined the class, it would allow me to join. But if you get more problems, just let me know and we can fix that. That serves to explain how to